Hello everyone. In our last sessions, we have seen unit circle and positions A, B, A dash, B dash. Why are they important to us? I continue here with observations from unit circle. And in this session, particularly, we will be learning that what are the angles attached to positions A, B and A dash and B dash. Initial position of moving point P is position A, where theta is 0. If you remember from previous sessions, theta was the angle made by OP with positive x-axis. If initial position of point P is same as A, then corresponding angle theta is 0. And then what we do, we allow point P to move in anti-clockwise direction and it completes one circle starting from position A. And it comes back to its position. That means it comes back to position A. Then how much is the angle covered? It is equivalent to, that moment is equivalent to 4 quadrants, 4 quarter circles. Means 4 quarter circles means 4 into pi by 2. That leads to 2 pi. This is one way of understanding. Other way could have been that it covers 360 degree. 360 degree means corresponding angle covered is 2 pi radians. So when point P completes one circle starting from position A in anti-clockwise direction, then angle covered is 2 pi. Then if you allow point P to move further in anti-clockwise direction and if it completes one circle, then what is the angle covered? Angle covered would be another 2 pi added to the previous 2 pi angle. That means total angle after completing second circle in anti-clockwise direction is 4 pi. That is 2 pi plus 2 pi. Now, if you allow point P to move further, or if it continues its journey further, then next circle would lead to another 2 pi. So total angle covered would be 6 pi. In further circle, it would be 8 pi and so on. Now, why point P has to move in anti-clockwise direction only? It could have moved in clockwise direction. Now just think that point P is moving in clockwise direction and it reaches back to position A. Then if it reaches back to position A, that means after completing one circle, it can do that. And what would be the angle? Angle would be kept with negative sign because in clockwise direction it is moving, and complete circle. So 2 pi. So total angle when it reaches back to position A would be minus 2 pi after one circle in clockwise direction. Okay. So one complete circle in clockwise direction gives you angle theta equal to minus 2 pi. Now if you allow point P to continue its journey in clockwise direction. So after completing second circle, it would be another minus 2 pi, which would be added to the previous minus 2 pi, and corresponding theta would be nothing but now minus 4 pi. So angle covered by point P by moving in clockwise direction after completing second circle, it would be minus 4 pi, right? Now, if point P further continues, then angles would be minus 6 8 pi. Maybe next circle it would be minus 8 pi and so on. So we can actually write all the angles in one statement now. Now position A corresponds to, now theta equal to minus 6 pi, minus 4 pi, minus 2 pi, 0, 2 pi, 4 pi, 6 pi. This is what we have seen. So this is nothing but the entire list. I'm showing the dots at the end, means it would cover all such angles, minus 6 pi, minus 4 pi, etc. Now, if you observe this minus 6, minus 4, minus 2, 2, 4, 6, these are all even integers. So basically, perhaps we are writing here even multiples of pi. Only element which takes my attention is 0. Now, does 0 belong to the same list as even multiple of pi? Now 0 lies between minus 1 and 1. Minus 1 and 1 are two odd integers. So 0 is an even integer for sure. So 0 which I have shown here in the list can also be considered as even multiple of pi. So basically this is, the entire list is nothing but even multiples of pi. Now, can I write this entire list in more concise form? Now, in language, I am saying it is even multiple of pi. Mathematically, how do we write? We write it as 2n pi. Why do we write it as 2n pi? If some of you do not know that how do I write this, for them, this is the following explanation. N is an integer. When you multiply 2 to it, it would become an even integer. So 2n is an even integer. You multiply it to pi, so it will give you even multiple of pi. And what n stands for? N is any integer. So I say n belongs to z. I'm sure belongs to notation is known to you. Capital Z I have written here for set of integers. Now, another way is you write in statement that theta equal to an even multiple of pi. It is just a statement, like in language you are writing. Okay. So this is how we have covered point A and corresponding angle theta. Now we have learned how much is the angle attached to position A. Now our concentration is at position B. That means point P from starting position A first will have to be brought to position B. How does that happen? That point P moves in anti-clockwise direction and covers one quarter circle and it reaches to position B. Now what would be the angle covered? Angle would be 90 degrees. I prefer to call actually angles in radians. So instead of degrees, let me call radians. So I would say point P from position A reaches position B by moving in anti-clockwise direction and corresponding angle covered is theta equal to pi by 2 in radians. Now from previous case of position A, some idea, some hint we have. What? That if I allow point P to complete circle, to have one complete rotation, one complete circle, it would reach back to position B. And one complete circle is equivalent to what? It is equivalent to 4 quadrants. One quadrant, 4 quadrants means angle corresponding would be 2 pi. Now, by covering angle 2 pi, it reaches back to position B. So, total angle is how much? Total angle would be 2 pi plus pi by 2. That means first pi by 2, that is one quarter circle, and one complete circle will give you 2 pi. So, total angle is 2 pi plus pi by 2 and point P reaches back to position B. Now who stops us? Point P can further move and then another 2 pi would be added and then corresponding angle would be 4 pi plus pi by 2. Why do I say 4 pi plus pi by 2? Because initially one quarter circle was pi by 2. Then one complete circle gave me 2 pi and now this second complete circle gives me another 2 pi. So corresponding angle is 4 pi plus pi by 2. Now, if point P continues its journey, means one complete circle again it takes in anti-clockwise direction, then corresponding angle would be another 2 pi will have to be added in 4 pi plus pi by 2. So angle would be 6 pi plus pi by 2. One more circle if it completes, then it would be 8 pi plus pi by 2 and so on. So what is happening is you are allowing point P to move only in anti-clockwise direction right now. So this entire story was about when point P moves in anti-clockwise direction. If point P moves in clockwise direction, then what will happen? Then first, it will have to reach to position B in clockwise direction. So clockwise direction means now 270 degree it will have to cover, right? But in clockwise direction. So angle will have to be kept with negative sign. And 270 degrees how much in radians? It is 3 pi by 2. So I will say point P reaches to position B by moving in clockwise direction and it covers correspondingly angle theta equal to minus 3 pi by 2. Now, if point P continues its journey and now take another circle in clockwise direction, that means how much angle will have to be added? It would be minus 2 pi, right? So, minus 2 pi minus 3 pi by 2. These two are to be added when point P reaches back to position B by moving in clockwise direction. So minus 2 pi minus 3 pi by 2. This gives me minus 7 pi by 2 on simplification. So corresponding angle covered is now minus 7 pi by 2. Okay. Now, if I allow point P to move further, means now minus 2 pi, another minus 2 pi will have to be added to this minus 7 pi by 2 and so on. So I can write from here a list of angle theta. Now minus 7 pi by 2, minus 3 pi by 2, pi by 2, 5 pi by 2, 9 pi by 2. These all we have covered here already. Okay. Now additional angle minus 11 pi by 2 I have shown here only for you to make some pattern here or to observe some pattern here. See, pi by 2, 5 pi by 2. If you see the numerator, you will see there is a difference of 4 pi there. Now 5 pi and 9 pi, again, there is a difference of 4 pi. So if you move on the left, that means now you will have to subtract. Okay. So pi minus 4 pi will give you minus 3 pi. Now, if you subtract further 4 pi from minus 3 pi, you will get minus 7 pi. So now you know why minus 11 pi by 2 is also in the list. Okay. Now, this is list of angles. If I want to write it in concise form, then how do I write it? Now remember one thing, position A is actually 2n pi corresponding to theta equal to 2n pi. If you add pi by 2 to it, you are adding pi by 2 plus pi by 2 is there, angle positive pi by 2. So if you are adding pi by 2 to it, that means you are moving in clockwise direction. So where would you have reached? You would have reached obviously at position B, and we are talking about position B only. That means 2n pi plus pi by 2. This is the angle corresponding to position B. This is another way of understanding, or you can actually check all these angles what I have listed here in the statements also. They all get fit into this 2n pi plus pi by 2 notation. Okay. So this is how we have considered position B. After studying angles attached to positions A and B, now position A dash turn has come. Now we have to see what is the angle attached to position A dash. For that, what we will do? We will allow point P to start from position A, move in the anti-clockwise direction and arrive at A dash. How does it do that? By completing one semicircle. So when point P starting from position A moves in anti-clockwise direction, and if it completes one semicircle, corresponding angle covered is pi radians. I'm deliberately saying radians. We can see from picture it is 180 degrees, but I would continue saying in radians only. Okay. So angle covered is theta equal to pi. Now, if you allow point P to move further in anti-clockwise direction and complete one circle, that means corresponding angle is how much? It is 2 pi. So previous pi, another 2 pi. So total angle covered is 3 pi. So when point P initially makes one semicircle and then completes one circle in anti-clockwise direction, then angle is 2 pi plus pi, that is 3 pi. You allow point P to move further and make or continue its journey. So the journey is of another circle. So it is another 2 pi radians. Another 2 pi radians is added to previous 2 pi radians, and one semicircle initially was of theta equal to pi. That means total angle covered would be 4 pi getting added to pi, and that leads to 5 pi radians. So this story is about when you are allowing point P to move in anti-clockwise direction. Okay. Point P starting from position A could have moved in clockwise direction also by completing one semicircle in clockwise direction. Clockwise direction means minus sign will have to be kept, negative sign will have to be kept. I can see from picture it is equivalent to 180 degrees means pi, but then that pi has to come with negative sign. So I will say to reach position A dash, starting from position A by moving in clockwise direction by point P, we get angle theta is minus pi radians. If you allow point P to continue its journey in clockwise direction further, then minus 2 pi angle will have to be added to initial minus pi. What is that initial minus pi? That was corresponding to that semicircle. So minus 2 pi minus pi, when you add, you will get corresponding angle theta is minus 3 pi. Now, you can also allow point P to move further and another circle in clockwise direction, means another minus 2 pi will be added again to previous minus 2 pi. That will make minus 4 pi. And the initial one minus pi of corresponding to my semicircle we already have. So minus 4 pi minus pi, they have to be added, and then corresponding angle what you get is minus 5 pi. So let me make a list of angles corresponding to position A dash, and that I write as minus 5 pi, minus 3 pi, minus pi, pi, 3 pi, 5 pi, etc. When you look at those minus 5, minus 3, minus 1, 1, 3, 5, you realize they all are nothing but odd integers. So what are we talking about? We are talking about actually odd multiples of pi. So I can also write theta equal to an odd multiple of pi. But how do I write that mathematically? We know 2n is an even number. We have already seen. You add 1 to it, you will get an odd number. So I can write 2n plus 1 in place of odd number. So odd multiple of pi means multiply pi to 2n plus 1. That will give you an odd multiple of pi. So there are various ways to write those angles. So either you make a list, or you write in that mathematical form, or you write in language wording, like a statement. So this is about position A dash. Now after studying positions A, B and A dash and corresponding angle theta, now only point to be studied left is B dash. Now to arrive at B dash, point P has to move from position A to B dash by moving in clockwise direction, and 1/4 circle it has to move. Now, some of you may think that why I am allowing point P to move in clockwise direction only. No, we will be covering anti-clockwise cases also. But since I am seeing point B dash close to A, and just by covering 1/4 circle in clockwise direction, we can reach B dash easily or perhaps quickly. I am taking clockwise. But of course, we will be covering cases of anti-clockwise direction also. So right now what I am seeing is first quarter circle in clockwise direction, we get angle theta as minus pi by 2, and point P has reached position B dash. Now, if I allow point P to continue its journey in clockwise direction, and if point P completes one circle in clockwise direction, that means corresponding angle would be minus 2 pi. Remember one thing, if you want point P not to leave its position, either you add 2 pi or you add minus 2 pi. So what we are seeing here is we have added now minus 2 pi because point was moving in clockwise direction. So you add this minus 2 pi to minus pi by 2. Initial quarter circles minus pi by 2 is there. Don't forget that. So angle would be minus 2 pi minus pi by 2, which leads to, on simplification, minus 5 pi by 2. Now you allow point P to continue its journey in clockwise direction further, and it completes one circle in clockwise direction. Completes one circle in clockwise direction means another minus 2 pi needs to be added to previous minus 2 pi. That will give you minus 4 pi, and this minus 4 pi is to be added to minus pi by 2. That means total angle would be at this stage minus 4 pi minus pi by 2, and that leads to minus 9 pi by 2. Okay. Now, in all these cases, we were allowing point P to move only in clockwise direction. Now, as I said before, we have to consider cases when point P moves in anti-clockwise direction. That means starting from position A, you allow point P to move in anti-clockwise direction and let that point P reach position B dash. When does that happen? when it covers angle 3 pi by 2. Why do I say 3 pi by 2? Because angle covered here, I can see it is 270 degree. 270 degree means 3 pi by 2. So angle covered by completing 3/4 circles is 3 pi by 2 in anti-clockwise direction, and point P has reached now B dash. Now you don't want point P to leave position B dash. Why? Because we are studying position B dash, right? So when you allow point P to continue its journey for another circle, that means you will have to add 2 pi to it. Completing one circle in anti-clockwise direction means angle is correspondingly 2 pi. So we add 2 pi to 3 pi by 2, and on simplification, I get angle as 7 pi by 2. Okay, so by doing this, we allowed point to P to move in anti-clockwise direction. Now let me make corresponding angle theta's list. Corresponding to position B dash, angle theta is minus pi by 2, we have seen in the list. Minus 5 pi by 2, we have seen in the list. Along with the statements, minus 9 pi by 2 also we have seen. So minus 9 pi by 2, minus 5 pi by 2, minus pi by 2, 3 pi by 2, 7 pi by 2. These all we have seen in these statements. I'm adding to the list 11 pi by 2 also. Why do I do that? For you to understand that there is some pattern, right? See the differences in minus 9 pi, minus 5 pi, also in minus 5 pi, minus pi and 3 pi, and so on. That would make you understand why I have added 11 pi by 2 also to the list. You want, you can write further angles also, or maybe previous angles previous to minus 9 pi by 2, etc. Another way of writing it in mathematical form is 2n pi minus pi by 2. Why do I say so? 2n pi minus pi by 2? Because position A corresponds to even multiple of pi. So that is 2n pi. And when you move in clockwise direction by angle of 90 degree, 90 degree means pi by 2, but you are moving in clockwise direction. That means you will have to add minus pi by 2. So 2n pi minus pi by 2 would be the angle corresponding to position B dash. This is what is in mathematical form. So this is how we have found angles corresponding to all positions A, B, A dash and B dash. So in this session, we have learned what are the angles attached to positions A, B, A dash and B dash. Now there are some more conclusions with help of unit circles which you can find that will be covered in our next sessions. Till then, stay tuned. Thank you.